Let's go over problem application exercise 4.6. It's a really important problem, and some of it's largely review, but some of it's pretty new and pretty interesting. So here we go. I apologize for the quality of the slide. There's another way to bring stuff in from the text, and I didn't do that. But let's just summarize. The given information here is the following. There's a lot of it, but we know that the marginal cost of abatement, of cleanup, for firm 1 is 0.3 Q1, where Q1 is however many tons they clean up. The marginal cleanup cost is, again, the cost of reducing emissions, not the cost of reducing parts per million of the pollutant at the receptor, not the cost of reducing the measure at the ambient standard. Anyway, the marginal cost for firm 2 of cleanup pollution is 0.5 Q2. All right, and then we also know a few other things. We know the transfer coefficient A1 is 1.5. We know the transfer coefficient for 2 is 1. And then we also know that without control, each emits 20. And what else do we know? We know the ambient standard is 12 parts per million. So that's our target. Well, where do we go? Part A asks us, if an ambient permit system were established, how many permits would be issued and what price would prevail? And remember that each permit allows 1 parts per million increase in the ambient standard. So this is the nature of the permit if you're enforcing an ambient standard. And it's important to keep that straight because it's different than if it's a uniform pollutant and we're just going for the quantity cleaned up in aggregate. No, for this problem we're going for pollution units at the receptor reduced. And that's what the permits control for too. All right, let's dive in. Is to find out what's the ambient standard without control. So without control, ambient standard is 20 coming from firm 1 times 1.5 plus 20 coming from firm 2, but their transfer coefficient is just 1, so that amounts to 50 parts per million without control. And so we want to get down to 12, so we have to clean up 38 parts per million. Now remember, that's not pollution units cleaned up, emission units cleaned up. That's how many parts per million we want to bring down the pollution at the receptor. So each of these permits, again, allows 1 parts per million increase in the ambient standard at the receptor. And now we want to find the efficient allocation of permits. And actually, the methodology here is very, very similar at this point to our methodology and application exercise 4.3. So here, we know the condition of efficiency is if we're achieving the lowest cost abatement, we know that the marginal cost of reducing pollution at the receptor is equal to the marginal cost of reducing the pollution divided by the transfer coefficient. So MC1 divided by A1 should be equal to MC2 divided by A2. That's the key to this problem. And I say it like, oh, that's all there is, but no. There's a lot to this problem. So, but that's the key relationship. And we know if this relationship holds, we can plug in numbers. 0.3 Q1 over the transfer coefficient is 1.5 has to equal 0.5 Q2 2. That's the marginal cost of cleanup pollution divided by the transfer coefficient, 1.0. And when we work all that out, we get 0.2 Q1 is equal to 0.5 Q2, and simplifying Q1 is equal to 2.5 times Q2. So there's an infinite number of points that satisfy that relationship, but we know a little bit more. We know that we're going for 12 parts per million at the receptor. I'm going to do it two ways, one and their equivalent. 1.5 times the pollution emitted from firm 1. And remember, that's the 20 they were emitting minus the amount they cleaned up. That's how many parts per million at the receptor result from firm 1 emissions. And then firm 2 is going to be emitting 20 minus however many they clean up. We know that the total there has to equal 12 parts per million. And we can simplify 30 minus 1.5, pardon my handwriting, 1.5 Q1, that's a 1, it looks like, I don't know, a 7 or something, plus 20 minus Q2 equals 12. And when we simplify that, we get 1.5 Q1 plus Q2 equals 38. And that's also the same as how much we clean up in terms of the parts per million at the receptor has to equal the 38 desired cleanup at the receptor. So those two relationships are the same. Now we can substitute what we know about Q1 and Q2 from the marginal cost of reducing pollution units at the receptor. Remember, we had Q1 is equal to 2.5 Q2. We can plug that in for Q1 here, and what we end up with is 1.5 times 2.5 Q2. Remember, that's what Q1 is also equal to by that other relationship. I'm sorry, I put an equal sign there. I wanted that to be a plus. Q2 is equal to 38. And when I simplify that all out, I get 4.75 Q2 is equal to 38. And that looks like a mess, but it turns out this is a canned problem. I don't promise to get everything to work out round numbers for the quiz. But when we divide both sides by 4.75, we get Q2 equals 8. And we know that Q1 is 2.5 times 8. 2.5 times 8 is 20. So firm 1 cleans up everything in the solution.